In this video, we're going to take a look at creating this part from the Model Mania Design Challenge at SOLIDWORKS World 2003. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where you're given a drawing similar to this and tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't challenging enough, when you're done, you're given a second drawing that entails many design changes, which again, you need to quickly create and make the changes as quickly and accurately as possible. The real catch is you never know what those changes are going to be. So let's go ahead and take a look at this drawing and some of the features that are going to go into this part. The first thing you'll notice is there's this combination of a dome and a flange that are both detailed out extensively in this top view or in this front view. They can also be seen very clearly in the isometric view in the upper right hand corner. Of note are a few key dimensions. Notice that the center of the circles in the arcs of the flange feature are defined by a 46mm bolt circle dimension. You'll notice that the radius here is defined in parentheses, meaning that it's a reference dimension. Specifically, that arc needs to remain tangent to the 70mm diameter circle. So that gives us some direction for the order in which we'll create these features. The next main feature is this ledge that kind of comes off from the bottom of this part. We'll want to make sure that we tackle this appropriately, and there's a few unique ways you can look at approaching this. We'll take a look at a few different methods. And then finally, the wall on the back side with a fillet, and then several holes and counterbores that go into the part. So let's go into SOLIDWORKS and get started by creating a new part. Now, I mentioned that the bolt circle of that flange is defined somewhat by the dome feature itself. So that seems like a good place to start. I'm going to draw this on the front plane because I want to draw this from the orientation that we're looking at it. And I'm going to start just by drawing a circle and specifying the 70mm circle here. Now, what I want to do is I want to revolve this. So I'm going to go ahead and I'm going to draw a line down from the middle. And to make things easier, I'm just going to trim half of that circle away. And the reason I'm going to do that is because when you do a revolve of a circle, you only ever want half of a profile. Now you'll notice up in the property manager that no axis of revolution was specified. And this is because we didn't have a construction line inside of our sketch. That's okay. We're going to go ahead and select this vertical line that we just created. Now notice that it's creating a full 360-degree sphere. We don't need that. We only need 180 degrees, so let's type that in. And in this case, it's revolving away from us, and we want it to revolve towards us. So we'll flip the direction and then press OK. So we kind of have that first feature, and this really gives us what we need to create the next feature, which is going to be this flange. Again, I'm going to draw on the front plane. I really find planes being a much better surface to draw on when possible than, say, for instance, the back face of that part. Now, this flange profile is a very common thing to create in mechanical design. It usually consists of a circle surrounded by two smaller circles and some tangent lines. Let's look at how we do this in SOLIDWORKS. The first thing I did is, you notice really quickly, I went ahead and created the circles. Now what I'm going to do is I'm going to draw some lines. And you'll notice that if you click and drag a line off of a circle, SOLIDWORKS maintains the tangent relationship. SOLIDWORKS also, when hovering over an arc, will try to snap to the tangency if possible. So we're going to replicate that 4 times in this case. I'm going to draw these 4 lines, snapping them to those tangent locations. There I missed it, so I'm just going to go ahead and delete that, and I'm going to redraw that this time. Looks like I'm struggling pulling that straight out of there. There we go. We got it the right way this time. And we've got what we're looking for. Now there's a few things we can do at this point. The first one is we can trim this out. Now we don't have to. We could leave those circles and we could use contour selection later on. But I want to show a few things we can do here. One of the next things we want to keep in mind is that these two arcs need to be the same radius. So by holding the Control key and selecting those, I can choose from equals in the pop-up menu. Likewise, I know that this arc needs to be tangent to the outside arc of this sphere. So I'm going to select those two entities and choose tangency. Now you'll notice what's happened down here. Notice that this arc is still free to move. That's because they have to be the same distance off from the middle. A great way to capture this is with a center line between the two circles and then create a midpoint relationship to the center of the center circle. And there now you'll notice that they always maintain the same distance. Now there's several dimensions still missing here. Let's go ahead and quickly add this radius, which we know is 20. Now, I could type in this value of 12 millimeters, but that's not what we're given. We're actually giving a bolt circle diameter. And you could do this several ways. You could just dimension the length of this, for example, and in this case it's 46, and that's going to capture it. Or if you really wanted to capture this in a circle form, you could draw a circle out from the center, snap it to this point, but remember you'll probably want this to be a construction line so it's not included in the extrusion. Now you'll notice that when I dimension this, we're dimensioning this by a diameter value as opposed to a linear value. Now the last thing that we need to capture here is this angle. You'll notice that it's free to move. Now there's a couple ways you could do this. You could draw a center line vertically straight up and then go ahead and add a 15 degree angle there. But another way you can do this without needing to create that construction geometry is you can actually dimension to the system planes. Notice that my right plane happens to fall vertically when we look normal to this sketch. I can select the right plane and that construction line and create the same dimension we did before. That's a nice way when you want to avoid excess geometry. All that's left in this case is to go ahead and extrude this, the thickness of the part, which is 50 millimeters in this case. Now let's go back to this drawing. This ledge at the bottom can be created multiple different ways. It could be done with thin features, multiple profiles, etc. We're going to take a look at a few different ways you could do this. One of the first ways is using multi-body. We can start with that ledge on the outside working with known dimensions. I'm going to go ahead and start with a sketch of my front plane, and we're going to go ahead and we're just going to draw a rectangle out here in space. We want the 3 millimeter offset off from the bottom and the 50 millimeter width. Now you'll notice I know the dimension from the center to the bottom is 50 millimeters. Conveniently, my origin is located at the center of that circle. That wasn't by coincidence. That's because we intentionally drew everything from the center. Now again, I'm going to go ahead and dimension from the center, and this time we're going to dimension to the outside here, and we're given 110 millimeters. Now you'll notice what I'm going to do here. I have a sketch floating out in space. We can go ahead and take this and choose to extrude, and I'm going to just go up to this face. Now the reason I use up to face is so that if this thickness ever changes, notice that that platform always maintains that same distance. Let's go ahead and type in 50 to restore that. Now how do we tie these together? This is where the thin feature really comes in. What we're going to do is we're going to draw a line straight out horizontal, and I want to convert to a tangent arc. An easy way to do this in SOLIDWORKS is to just move your cursor back to the line and come straight out. And in this case, I'm looking for that vertex there. I'm going to just drop this here for right now and go straight back to it. And I'm going to manually select these two and choose coincident. And I'm going to grab that edge and that arc and make those tangent. That might have been a little bit confusing to see on the drawing, and I do apologize for that. So we've got that done. Let's go ahead and now use this. Like before, we're going to do an up to surface just so we always maintain that relationship. And notice here, SOLIDWORKS has automatically recognized we want this to be a thin feature. All we have to do is specify that width of 10 millimeters and set it in the right direction and press OK. So there we've done that with a combination of a multi-body and a thin feature. Another way we could have done that, let's go ahead and delete both of these. Let's go back to this sketch right here. I'm going to keep that dimension that we're working with in this case, and notice what I'm going to do. I'm going to actually draw over top of this, and you could do this a variety of ways. We could have done this all in one sketch. I'm going to go ahead and make this tangent here and here, and then in this case what we do is we're going to offset this 10 millimeters. We're going to reverse the direction, and let's go ahead and close that, and then let's go ahead and cap the ends. Now, one of the reasons I don't like using this is there's a lot of extra geometry. Notice the thin feature was a little bit easier. And then what we can go ahead and do in this case, we can get rid of all that extra geometry in there. And in fact, let's change the way this is done a little bit. Oops. Let's extend that. Let's do trim to closest, and we'll choose to extend. There we go. And then we could have done this all as one profile as well. So many different ways you could have tackled this same challenge. I just showed you several different ways you could have done it. We're going to go ahead and we could have actually kept that feature the way it was with the extrude up to next, but I wanted to show you a variety of different ways you could have handled it. There you go. Let's go and look at creating that back wall now. Again, I'm going to go ahead, I'm going to draw this on this face. Actually, I'd be cheating if I'm going to go ahead and I'm going to show you some of the advantages of drawing on a face. I'm going to go ahead and we're going to reuse some of this geometry. So I'm going to use convert entities. Notice what that's done. It's copied that geometry onto this profile for us here. And then all we have to do at this point is draw basically the rest of that rectangle. And then let's go ahead and add a fillet in this case of 20 millimeters and trim the rest of this geometry away. We use power trim for that. And a height is given to us here, 40 millimeters off from the bottom. So there we go. All that's left for us to do is choose to extrude this, make sure it's going in the right direction and the right thickness. Now look what's happened. We have a bit of a problem here. It actually can't create the extrusion for us, and the reason is something called zero thickness geometry. And that's because when we extrude this up, we're going to create this tiny little wedge down here. If I uncheck merge results, it's easy to show what's happening. You get to a spot right here where there's actually virtually no material. So how do we solve this in this case? Well, one of the ways we can do this is by changing the way we create this sketch. And I'm going to do that by just simply continuing this geometry up. And what I'm going to go ahead and do is I'm going to create a corner fillet between those two entities. And now when I close this, you can see it brings them together. Now one of the things we want to do is we want to change that from not merging to merging with one another, and then that'll join all that material together in that location. So a couple things to watch out for right there. So we've got that done. What do we need to do next? It looks like we need to add some holes and some counterbores. So let's go ahead and do that now. We also need to hollow this out on the back side. So let's go ahead and draw a sketch here. We're going to do this very similar to the way we did it before. We could do this with an offset, but I'm going to dimension the circle off from that outside edge. I like to create it this way because an offset wouldn't give us a full circle and we might not get exactly what we're looking for. But we're going to create this identically to what we did before by trimming that outside. And this time we're going to choose cut, obviously, instead of extrude. And again, choose that center line as the axis of revolution. Notice this time we don't need to limit the angle to 180 degrees because a full 360 cut is going to give us exactly what we're looking for. There's also a cut that comes off from this top face right here, and that's a 25 millimeter diameter. Let's enter that value in. I typed in the wrong value. And let's go ahead and choose to cut, and I'm just from the right click menu going to choose through all and right click to confirm. The last thing we have is a series of counterbores and then some fillets we'll have to get to. Now, I'm going to create these counterbores right now. And then I'm going to go back and show you how order of operations can affect this. Let's go on this face. I'm going to create a counterbore, and you'll notice it gives you all the dimensions, but notice at the bottom it says standard counterbore for a 6 millimeter socket head cap screw. So we've got all that information already specified. Notice the end condition through all. And for positions, we're going to snap this to the middle. And you'll notice here I have a little bit of trouble grabbing that edge. Well, here's an example, again, of where you could use the construction line trick that we showed you earlier to tie two things together. You'll notice here now I can snap this to the origin, and when I make those midpoints, that's always going to fall the same distance away. Let's go ahead and confirm that. And then we have two counterbores on this top face right here. So let's go ahead and choose to add those as well. And they're the same size. So we're just going to go about creating these and putting their positions in place. Now what I want to do here is I'm going to dimension, this is 20 millimeters off from the back edge here. They're 20 millimeters apart both vertically and horizontally. So we're just going to dimension from point to point. And then finally there's a distance off from the center of 75. Again, I'm going to use the origin dimension to here is it's something easy to pick and it never moves or changes. So let's go ahead and press OK. And we pretty much have everything we have in the orthogonal views, but notice in the isometrics there's lots of fillets that go on this part. So let's go about creating those now. These are 3mm fillets, so we'll enter our diameter. And if you've watched the previous videos, you probably realize I really like grabbing faces. And one of the reasons is faces happen to capture a lot more geometry in one pick than grabbing individual edges. The problem with grabbing faces is sometimes you can't create them. And the reason is it's trying to create a fillet on this edge right here. If you remember a moment ago, I said one of the things we could do is we could change the order of operations. Notice the difference if I, before this fillet, now try to create that 3mm fillet. SOLIDWORKS has no problems creating that. Though in this case, you'll still need to grab that corner. We do want to grab these edges right here. And we'll want to grab these right here. Now you'll probably wondering why this face specifically. Well, if I grab this face, it's going to try to put a fillet on that outside edge, which again, it doesn't like because of the way this fillet blends in right there. We also have a fillet on this inside edge right here. I'm going to go ahead and grab that face right there. And it looks like we have them all except for that one right there. Now, what if we wanted to keep that order the same? So for example, I create my counter bore and I want the fillet to come at the end. Notice it's going to give me a warning here. All we need to do is choose not to create the fillet on that face. And notice because I chose this face, the tangent propagation option allows the fillets to continue the way we had them before. So just a few tricks there when working with fillets. Keep in mind the order you create them can have an impact on how they look. So there we go, we've got our whole part done. Everything looks great. So what happens next? We're given phase 2 of the drawing where we need to make some changes. If we look at these changes, there's some very significant ones here. The first thing you'll notice is that this rib along the back has been repositioned from the back face to the front face. That's a huge change on this part. Additionally, the location of these holes has been affected. We've changed the distance from the center, but also that back edge isn't there anymore, and we've changed the dimension to 10mm. Going to the front view, you can see that there's now this big tangency between that back face and that boss as well. And then finally, there's this extra material that's been added. So we've got all sorts of changes. This is a really tricky part. So let's dive in and take a look at how we'll approach this. One of the things I like to do in a part like this is I think it makes sense to roll back and take a look at this feature by feature. The dome hasn't changed. None of the dimensions have been affected. But if we take a look at the next feature, we do see several changes in this case. I'm going to go to a front view, and the angle of this has changed to 30 degrees. So let's go ahead. That's pretty simple. We type in the new angle, everything updates perfectly. Then when we move along, this ledge that we've created, well, conveniently, nothing about that ledge has changed. So we're not affected by that. Now, here's where things get interesting. This face needs to not only move from the back of the part to the front, it also has to have a rather large radius added to it. So let's take a look at how we'll tackle this. I'm going to do this by changing the face in which this was drawn on. And to do this, we have to access the sketch. And you'll notice you have the ability to edit the sketch plane. Now, remember when I created that, I chose that face and I said it was a bit of cheating? Well, I knew that this was going to be created on this face. Now, when I do that, it makes the change pretty simple. It does still fail in this case. And the reason is we're going to end up with that zero thickness geometry issue right there. But if we change the direction to the inside, notice it solves no problem. But what about that fillet that we wanted to create right there? The best way to capture this is in this same sketch right here. And what we're going to go ahead and do, let's go over to this view. Let's go normal to and then normal to again. There we go. We want to create a tangent arc off from here down to here. So I'm going to go about doing this by creating a 3-point arc. This is going to require what I would call a little bit of manual work. So we get the tangency. We need some more of this geometry. You'll notice what I'm going to do. Actually, I'm going to delete that. I'm going to show you another way we could have done that. I need this arc, and this arc. And by convert entities, we're going to use those. Now when I create a tangent arc, you'll notice I can come straight off of there. So it's a little less manual than what it would have been. But down here, we still need to make these two tangent to one another. Now we have a mess here that we really want to clean up. So I'm going to go ahead and I'm going to access the trim tool, and I'm going to start by cleaning up some of this geometry to close that profile. And just like that, you can see if I close the sketch, we've now got that feature. Now, this doesn't mean that everything else that happens after this is going to be convenient. Let's take a look at what happens. We're going to go ahead, here's our cut. Here's our cut extrude through, no problems. Here's our counter bore. Now, if you had created that counter bore to that arc, you may have had problems with that updating. What about these counter bores here? Notice they don't even appear. And that's because if you remember, we dimensioned them to that back face of that ledge there. So let's go ahead and look at that sketch. And notice what it's doing. It's dimensioning it to that face. But these dimensions have changed. And instead, they're dimensioned off from this back edge by 10 millimeters now. And this dimension here is changed to 85. I noticed that that's a little close. There was actually another change that took place that I skipped over. We missed a dimension. We need to go back here. This dimension was 120. There you go. Now you can see that counter bore made it very obvious what we had missed there. And we're going to save the fillets for last. There's a big piece that's missing here, and that's all this material that needs to get added to the inside right here. So how are we going to go about doing this? This is a great place to use convert entities and up to next extrusions. What I'm going to go ahead and do is I'm going to start a sketch on this inside face, and I'm going to choose to just copy all that geometry. Then we know if I look straight at this, it needs to be this intersection area here. So here I'm going to use convert entities again, and I'm going to grab this outside arc and choose to copy that as well. Now you could trim all this up, but keep in mind, selected profiles, or selected contours rather, allows you to just select a region that you want to work with. Then all we need to do is choose, normally up to next would be an option here. Sometimes when it's not, you'll want to use up to body and just select the body of the part, and notice how it fills that in for us. Now, because of that big change right there, that one more than any, we're potentially going to have problems with our fillets right here. Some of the faces that we had selected previously no longer exist. And notice it says this, there's a face missing. That's okay, we're going to go ahead, we're going to delete that from our selection, but it's still not solving. Why is that? Well, now we're running into a case where sometimes you need to create fillets in a slightly different order. So notice what I've done there. I'm going to select these in a slightly different order to make sure I get what I need in this case. And there we go. It looks like it's cleaned that up. We've gotten everything we need and everything else is preserved on the outside. All we'll have to do is at the end create this last fillet as a separate feature here. Now you could have done this in a variety of different orders. That's just one way you could have gone about that. So there you go, the Model Mania Design Challenge from SOLIDWORKS World 2003. This one had a lot of changes to the second phase, but hopefully you can see how SOLIDWORKS' robust capability to make changes on the fly made it not too difficult after all.